New York City just got hit hard. On Saturday, July 18, 2026, a few hours of rain turned streets into rivers. Cars sat half underwater. Drivers needed rescue. Water poured into subway stations. 2 to 4 inches fell in places, some of it at rates of nearly 2 inches an hour. The air over the city held so much water it could not keep it up there any longer. Yet the same kind of sudden dump keeps happening more often. Why is the sky holding more water than it used to? And what does that mean for the ground we stand on? This story gets stranger the deeper we go. What we know is clear. Heavy thunderstorms moved across New York City, Long Island, and parts of New Jersey on July 18th. Rainfall rates climbed fast enough to overwhelm drains that were built for older weather patterns. People waded through ankle-deep and sometimes waist-deep water in Brooklyn and Queens. Expressways closed. Flights delayed. The storms followed days of heat and smoke from Canadian wildfires. Scientists have measured that warmer air holds more water vapor. For every degree Celsius the air warms, it can hold about 7% more moisture. That is the Clausius-Clapeyron relation, a basic rule of physics that has been known for a long time. Question number 1. If the air can simply hold more water, why does it suddenly let it all go at once? But then the numbers start to climb faster than that simple rule. Think about it for a second. If the air warms by 2 degrees, does that mean only 14% more rain, or something bigger? The answer is not always the simple 7%. In short, intense thunderstorms, the rain can climb even steeper. Scientists who study these storms have seen rates closer to 14% or more per degree in some cases. The extra moisture feeds stronger updrafts. Warm air rises faster. More water gets pulled up and then falls out harder. On July 18, the storm sat over the same areas long enough for the rain to pile up. That is called training. The cells kept reforming and dumping on the same streets. Urban concrete does not soak up water the way soil does, so the runoff has nowhere to go but the roads and the basements. Satellites in orbit watch the whole thing. NASA and NOAA instruments track the amount of water vapor in the atmosphere from space every day. They saw the moisture surge before the rain hit the ground. Question number 2. If we can see the moisture building from space, why does the flooding still catch cities by surprise? But that's not even the strange part. The same satellites that watch New York also watch the rest of the planet. They show the same pattern in other cities and other countries. Extreme short bursts of rain are becoming more common. Scientists who study the records say the 4 biggest rainfall events in New York City in recent years all happened in the last 4 years. The atmosphere is acting like a bigger sponge. When it finally gets squeezed, more water comes out at once. That is why a storm that once would have been heavy now turns streets into rivers in under an hour. The concrete city does not have time to drain. Basement apartments fill. Highways close. People get stuck. And the same physics that rules the air over New York also rules the air over every other place on Earth. What does that actually mean for the ground we live on? It means cities built for the weather of the last century are facing the weather of this one. Drainage pipes sized for older storms cannot keep up. Low-lying neighborhoods flood first. The people who live in basement apartments face the highest risk. Space agencies keep launching better sensors to measure the moisture and the rain from orbit, yet the water still reaches the street faster than the warnings sometimes do. Question number 3. If the air keeps holding more water every year, what will the next decade of summers look like where you live? The image that stays is simple. A street in Brooklyn on July 18th, water rising around the tires of a car. People walking carefully, with children on their backs. The sky had held more than it could keep. The same sky is still holding more every year. The question is not whether the next dump will come. The question is how ready the ground will be when it does. Would you rather live in a city that plans for the old rain or the new rain? If this changed how you see the next thunderstorm even a little, share it with someone who still thinks rain is just rain.